Hey everybody, it's Cheri Dotterer, your classroom coach. We are here at Tier 1 Interventions. I am with my co-host Jonily, and we are going to be talking today about the candy problem.
Yes, just based off of what you just said. So if you are looking to have teachers invest in this idea, is it better to relay information like this, adult to adult, or provide experience for them, or both? I don't know.
That's a really good question.
Because I do know our experience as teachers is tainted, right? Because they're going to come in and I'll be like, oh, 90 candies and 2 to 3. And all of a sudden they're writing algebraic equations and doing the fractions 2/5 or whatever the different things are. So I understand it's not as genuine as an experience with kids. So then I'm like, okay, so then is it really, I'd have to get the opportunity to model it in with their students in front of them to get them to, yeah.
So there's a lot of answers to that question. I don't ever want to, I cannot treat adults like I treat kids. We're different people. And the last thing that I want to do as an instructional coach for adults is to insult their intelligence. Like they're going to see right through the fact. So I'm going to tell them it's going to be very difficult for me today to give you experiences that you can replicate with your kids. And I tell them all the time, the way that I'm facilitating this with you is not the way that I'm facilitating it with kids. I'm going to have to tell you how I facilitate it with kids and make that explicit. And then I want you to listen to my audios so that you can get that chef flavor. So sometimes I can only learn from a chef by watching the chef and then asking questions. So it's the same way with our adults because it's very counterintuitive. If I am learning how to cook chef like with a recipe, but with that flair, with the special ingredients and the special way a chef does things, I'm going to have to watch the chef multiple times. I'm going to have to ask questions and I'm going to say, oh, did you mean to put that much in or that little in? And then the chef might be like, you know what? I did this time, but last time I put more. So there's a whole coaching back and forth. There's a whole toggle. There's a whole interaction and conversation that happens. That's what instructional coaching is with our teachers. And we have to explicitly explain that to them. I can't put you in the same situations of our kids. So when I do this with an Algebra 1 kid, I'm also going to facilitate it differently than when I do this with my fourth graders. So you have to listen to the audios, and that's why we provide those for you. And if you are an instructional coach, you can use those audios as part of your professional development with your teachers also. Now, I do tell teachers I have to sit and get you because you want to learn as much as possible. You just want me to state the facts to you, and I want to do that to appease you. But then what I do is I say, I'm going to give you a math problem today that is not one that I typically give kids. It's not one of our reference tasks, but it's one that I want you guys to engage in today. And here's the one that I always, Sarah, to your point, I always have in my professional developments all of the above. But I will always have one problem that is experiential for the adult learner. And my favorite problem for the adult learner, this one is fun, you guys. It is called the car problem. The reason it's not a reference task is because for a couple of reasons. One, it's not easy to facilitate. It's a high level counterintuitive math problem. It deals with rate, and not many adults would actually get the correct answer to it. Even my high school teachers are like, oh, I don't teach work rate problems, so I don't remember how to do that. So this is a good one. Here's the car problem. We are traveling from A to B, and it's 100 miles. So I'm traveling to my cousin's, my house to their house, it's 100 miles. Then I do the return trip. So I go B to A. On the go-to trip, I'm going to travel at 40 miles per hour. On the return trip, I travel at an average of 60 miles per hour. I give my adults this situation, and then I say to them, I'm going to facilitate this with you how I facilitate it with kids. Because this is a good level for the adult math people in the room, but I can actually put them through the experience. So I'm going to say, and I'm also going to have to unpack it because as the adults in the room, all they want to do is solve and they miss out on the other agenda. The other agenda is, what am I doing to facilitate that is engaging you to have an urgency to solve? That's what we want to create with our students. So what happens oftentimes, I'll provide, and I'm not trying to toot my horn, but I am pretty good. I oftentimes, when I do a math professional development, I get people on the edge of their seat and they are so engaged and so focused. And they'll leave the professional development and be like, that was the best professional development I've ever been through. And they'll go back and try to replicate it. And they can't replicate it because they didn't unpack the hidden other agenda, which was the way that I was facilitating to make them feel that way. What I'm doing to you right now, that's what I'm doing to you right now. I give you this, and then it's not even about the math. You know that I've selected a good problem. If math well enough to be like, ooh, I would never really give that because I don't even know the answer. There's not even a question. So I don't know what answer you're trying to get right now. But I'm backing up and explaining to you my hidden other agenda, which is if you leave here today and go do this car problem with your people because you were like, ooh, she really piqued my interest when she gave that. The way that you're going to do it is not going to be a replication of what I'm doing because I'm not explaining to you the process of how I'm facilitating it to you. So I will explain to teachers what I'm doing to you while I'm doing it to you. Now, half of them aren't listening because they're trying to figure out what's the average speed of the whole trip. So then I'm going to be like, none of y'all listening to me because you're making up questions for this. See, that's what a good mathematician does. Don't you want your students to be able to do that? I'm giving you the tools to get your students on the edge of the seat. Sarah, to answer your question in a very lengthy way, because it's that important, we've got to use the toggle method when we're giving professional development to our adult staff. And I have to toggle between giving you an experience that you can actually experience and isn't artificial, but also just explicitly telling and sharing, and specifically sharing my hidden agenda. The way that I prep for this and the way that I facilitated it is why I had you on the edge of your seat. You can't go replicate that unless I teach you that part of it. Follow-up question on that. Sarah, I'm glad one of your people did this week. That was good. We had a fun year last year with your people. Yes, they do. Hey, here's my philosophy. If you don't have haters, you're playing it safe. The more haters you have, the more successful the implementation you're doing. Do I mention Super Bowl halftime show right now? Have you gone down that rabbit hole? You talk about a chef, you talk about messaging, curiosity, symbolism, radical actions. That's all I'm going to say about that. 1-800, my previous 1-800 save my kid. Y'all are awesome. Other thoughts? If you don't have haters, you are not taking enough risk and you're not changing and implementing enough. All of these problems, Candy, Jesse and Kay, car problem, paint problem, locker problem, quick dots, all of them have one common theme: counting. There is a progression of counting, and I want us to pay attention to this. Number one, the number one thing that we need to have all kids doing, and we always need to go back to this. If kids are struggling with division or operation or whatever it is, we need to make sure that we're doing rote counting with no meaning. 2, 4, 6, 8, who do we appreciate? Hey guys, we're going to count by halves today. You don't know what a half is? It doesn't matter. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. Rote counting. My second graders this year, I've been following since kindergarten. I have another project group. In kindergarten, we sang the 12 song. There's a YouTube video on this. And we just did it randomly. 12, 24, 36, 48, 60, 72. Somehow I always break out in song in these sessions. Anyway, we rote counted sing-songy with no meaning. And that is absolutely essential. Because what happens is through rote counting, kids start to develop meaning. My son called a butter knife a cutter for years when he was a toddler. I'm like, it's a knife. He's like, it's a cutter. I need the cutter. Okay? That made sense to him. Why isn't it called a cutter? Anyway, kids will develop meaning just by doing. Rote counting. Then we want rote counting. Now, this is going to be really counterintuitive from the way that I usually teach, because usually I'm like, you got to build the conceptual first. No, not in this case, not with counting. We just want rote counting, no meaning. And then we want rote counting still with no meaning, but we want to connect to symbols that kids don't understand. Look at this symbol I put here. I didn't explain what that symbol is. I still haven't. And I did that on purpose. I said, okay, this boy is going to get 2 pieces for every 3 pieces. And if a kid's like, why'd you put those dots? Isn't that like a time? And I'll be like, I just wanted to put those dots to separate how many pieces this boy gets and this boy gets. That's all I'm going to do so far. I'm going to use symbols without meaning. I'm going to use, so one of our other reference tasks is the square pizza problem. So I might say to kids one day, okay, we're going to do square pizzas with 24 pieces. And I'm going to write it like this. Now I'm going to use the square root symbol, but I'm just going to do that very nonchalantly. My kids haven't seen it before. I'm in 1st grade. I'm going to be like, okay, I'm going to do this check mark with a line. And today we're going to do square pizza problem. And you're going to make a square pizza with exactly 24 blocks. And they're going to be like, what's that check mark? I'm going to come around. I'm going to check to see if you've got this square pizza with exactly 24 blocks. That's what I mean by rote connecting to symbols. No meaning. This is exposure. We do not expose our younger mathematicians early enough to symbols, so then later on when they see the symbol for the first time, it's the same time we expect mastery. So we need to expose symbols much earlier on, not for mastery, just for them to start to understand the meaning. That's what I mean by rote counting. Okay, let's count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Oh, keep going. 101, 102, 103, 104. That's not correct, but I'm not going to correct them. I'm going to make note of which kids are counting like that because I know later on they're going to have issues with place value. These are what we call target questions, just like that target question I asked before. How much time from 1 to 3 o'clock? If kids say 3 hours, 1 o'clock, 2 o'clock, 3 o'clock, 1, 2, 3, I know those kids have a lower number sense than students that know that 1 o'clock is my zero number. It's my starting number. This is why Jesse and Kay is so important. My zero number is my starting number. So from 1 o'clock to 3 o'clock, 1 o'clock is my zero, 2 o'clock is my 1, 3 o'clock is my 2. So what's my zero here? For Jesse, my zero is 50. Day zero, today, my starting point is 50. Day one, Jesse will have $55. Day one is after 1 day. Day one is tomorrow. This is one of the most mathematically profound things we can have kids understand. But that meaning doesn't develop until after we've had rote experiences. Oh, guess what, guys? Today we're going to skip count by tens again. You guys do great at that, but we're going to start at 24. Go. Best wrong answer, kids are going to say, and this is actually a really good wrong answer. This is good if they do this wrong. 2430, 3440, 4450, 5460. If they do it that way, I'm actually very impressed, especially if they're a younger student. That's a much easier fix than if they give me random things that don't even make any sense. So we want kids to be able to rote count 24, 34, 44, 54. What's the next step? I give them a 120 chart. So the rote counting is just 24, 30, 34. Whether they do it correct or not, it doesn't matter. I move on to the next step and I give them a 120 chart. And I'll say, okay, let's circle 24. Now count on 10 more. Where do you land? 34. Oh, we don't land at 30, see? So we're connecting the symbols to the rote. Still, there's not going to be a lot of meaning. Now we are going to count with meaning. What that means is now I'm going to need some sensory pieces. I'm going to need blocks. I'm going to need sponges. I'm going to need centimeter grid paper, graph paper. I'm going to need those manipulatives. I need kids to touch and feel the mathematics. Guess what, guys? Today we're going to rote count by fourths. We're going to rote count by fourths. So get your paper strip out. To get fourths, we have to iterate. We have to iterate twice in half. We have to iterate. We have to fold in half twice to get 4 parts. And today we're going to count by fourths. Remember we did that and we messed up a lot. And then I showed you some of the symbols and the words for it. By the way, we don't want to show the fraction symbols too early. We don't want to show 1/4 too early. Early on, we want to just show whole numbers with words. 1/4, F-O-U-R-T-H. 2/4, 3/4, 4/4. So now, if I want meaning with the counting, we'll use a paper strip that has fourths. And then I'll say, okay, Amy, count one. Let's count all together, but we're going to use Amy's paper strip. 1/4, 2/4, 3/4, 4/4. Perfect. We're going to, Sarah, hold up your paper strip. 5/4, 6/4, 7/4, 8/4. Ooh, how many paper strips was that? 2 paper strips. It was Amy's paper strip and Sarah's paper strip. But how many fourths were there? How many counts did we do? We did 8. 8 counts of what? Fourths. Okay, so we do this rote counting. We have maybe not the fraction symbol, but this written language, 1/4, 2/4. So we're just counting by whole numbers with a word or a measurement symbol. And then now we're counting with meaning because we have that visual experience. Another one of our reference tasks is called paper folding. See how all of these things fit together. And every concept we teach in mathematics from preschool through high school all comes back to these 12 reference tasks. I really don't need anything else except these 12 reference tasks. Those are the only experiences we need to teach all of our standards. So we start to get this meaning when we embed these sensory. Now, what happens is when I start to create this meaning through these experiences with reference tasks, kids tend to become curious and creative, and we get a huge amount of engagement and focus. ADHD students don't have lack of focus, they have hyper focus. The way that we tap into that, and actually one of their biggest strengths is creativity. So the way we tap into that with our ADHD students is we provide these experiences where they can do, they can talk, they can listen, they can play, they can just interact with the experience, whether it's paper folding or blocks or whatever it is. And that will extract their extreme hyper focus. They will be so in the zone that I can't get them to leave the room at the end of the period. Now, if you have not ever had that experience with your students, you're doing it wrong. And I don't mean that to be a jab. I just mean do it better. Okay. And I can individualize this because for some kids, I can have them counting by halves, some fourths, and some eighths, but I'm doing the same experience in the same paper strip. It's accessible when I get to this point because now I've got all of those sensory development things that kids need. And why is the memory and retention going to increase? It's because I've engaged in all of the senses and emotions and feelings that Cheri always talks about that creates a green sticky note in the student's file cabinet of remembering. So all of this together with reference tasks will completely turn around all of our frustrations in schools as teachers. Now we're not finished. Counting progression is rote with symbols, still no meaning. Then we're going to count with meaning. I've given you a couple of examples of that. Next, we are going to count to operate. We are going to count to operate. This is where we are right now with candy problem. And I'm going to go pretty deep, high level candy problem in a moment. It's always about the last 20 minutes that I extend the mathematics in all these different directions. I'm going to go really mathematical with candy problem in a moment, but I can't rush there. I can't rush to the mathematics. I have to lay all the groundwork with you and with the kids before I start taking this up level. Then there's a fifth one after operate. Now, if you know, the numeracy cycle has 4 components. This is an intervention cycle when kids struggle with computing mathematically. The numeracy cycle says count, quantify is what is the value, what is the magnitude, how large and small. That's when we start to get meaning. Compare and operate. There are 4 components of the numeracy cycle. They're embedded in this. Count, quantify, compare, operate. If kids struggle operating, we have to go back to comparing number experiences. If they struggle with comparing, we have to go back to just the meaning, the value, the quantity, the magnitude. And if they struggle with that, we have to go back to rote counting with no meaning. Oftentimes we miss this step, especially when we start to teach fraction, decimal, or negative numbers. We never go back to the rote counting without meaning. And when we skip that step, we never get the full meaning that kids need to be able to compute and operate with efficiency and accuracy. But there's one more level to it. Counting, yes, we want counting for efficient, accurate operation and computation. But there's a bigger reason why we want kids to be efficient and accurate in their computation and in their operations of mathematics. And that is we want to count to rate. We want to count to rate. The greatest deficit for our secondary students in higher level mathematics is they don't understand rate, function, and iteration. Rate, function, and iteration. Rate is ratio, similar to ratio. So the three things that we really want to focus on are rate, function, and iteration. And we're going to use counting to do that. So I'm going to give you right now a secondary example of why counting is so important and why our high school students have counting deficiencies and how we fix it. So I'm going to give you two ordered pairs, 1, 3, and 4, 5. At the secondary level, we would give these ordered pairs and we would say, these two ordered pairs are on the same line. So there's a linear function here. I want to know what line, how you would describe the line these two ordered pairs lie. I want to go back to what we talked about earlier because we think that those two math camps that we live in, the procedural and the conceptual, we think as we increase grade level and get to secondary mathematics, we think that there should be more procedural than conceptual because math is much less conceptual. It's the exact opposite. If we do more procedural in higher level mathematics, we are actually negating math achievement. If we do more conceptual, we are increasing math achievement and number sense. What we're going to find is that the kids that struggle with rate function, linear function, slope, rate of change, when they struggle with all of that symbolic and procedural and they're not accurate in their solving and answer getting, it's because they lack a counting foundation. But it's not the 5th grade teacher's job to create the entire foundation. As an Algebra 1 teacher, it's my job to go back to this foundation. It's a cycle that's important at every level. We don't break this down and say, okay, we do this at K1 and then 2, 3, 4, 5. No, we do the entire cycle at every grade level. So if I'm looking at these two ordered pairs and I'm going to graph them on a coordinate plane and I want to talk about the line, I first want to study, well, what's my counting number? What's my skip counting numbers? What's my skip counting numbers? Just like in the candy problem we're going to do in a minute, I'm counting from 1 here to 4 here. And then here, I'm counting from 3 to 5. It's just counting. That's it. Ordered pairs are just counting. Graphing on a coordinate plane is just counting. And we don't teach it this way, and then we wonder why so many kids struggle. You talk about accessibility. Let's look at this. So from 1 to 4, how many counts is that? It's 3 counts. From 3 to 5 is 2 counts. What we tend to do next is the wrong thing. What we tend to do next is we say, there's this rule, change in y per change in x, which makes a ratio, which makes a fraction, that describes our rate of change or the slope on a graph. That's procedural, and that's fine, okay? But it's not going to increase our math achievement, and it's not going to give an experience to increase number sense. What I'm going to ask kids to do is I'm going to ask them to fill in more of this chart here. I'm going to ask them to fill in 0, -1, -2, 2, 3, 5. This becomes a counting exercise, which is an experience in improving number sense. So now they need to fill in the number that goes with 2 and the number that goes with 3. Usually, if older secondary kids can see this, they're going to be like, okay, look, I've got to have 1, 2, 3 counts. So I've got to go from 3 to 5 in 3 counts. Now, if I went from 3 to 6 in 3 counts, what would my skip counting number be?
2.
So if I go from 3, here, let me write it a different way. If I go from 3 to 6, but I need 3 counts, meaning 1, 2, 3, what numbers do I fill in?
Hey, everybody, this has been Tier 1 Interventions. We'll see you next week.
Bye, everybody.